everyone, and welcome to the 2021 virtual Gaithersburg Book Festival. I'm Phil Kaminsky, and I'm honored, humbled, and excited to be your host for tonight's presentation. Before we get started, I'd ask that you please consider sponsoring tonight's author by purchasing his book from our bookseller partner, Politics and Prose. You'll find the purchase links in the presentation description. If you consider the hardships we've been through over the past year, the choice to support local and independent businesses has rarely been more necessary. Thank you. We would also like to extend a big thank you to our 2021 featured sponsor, the David and Michael Blair Family Foundation, for their wealth of generous support. And here we go. Today, it is our utmost pleasure to have with us world-renowned theoretical physicist, Professor Michio Kaku, author of many wonderful books, but here today to speak on his most recent masterpiece, the New York Times bestseller, The God Equation, The Quest for a Theory of Everything. Today's physicists are on an epic adventure to combine Isaac Newton's laws of gravity and motion with the more recent discoveries of quantum mechanics and Albert Einstein's relativity, which, as of yet, have proven to be incompatible. Succeeding in this endeavor would ultimately tie all of the forces in the universe together into one beautiful equation that will unlock the deepest mysteries of space and time. And that fascinating journey is the story of this book. Professor Kaku is a professor of theoretical physics at the City College of New York. He is the co-founder of string field theory, and he continues Einstein's search for a theory of everything, one that unites the four fundamental forces of the universe under a single theory. He is the science correspondent for CBS This Morning, host of the popular radio programs Science Fantastic and Exploration, and the host of many, many terrific educational TV shows on BBC and the Discovery Channel. Welcome to today's program, Dr. Kaku.
After such a great introduction, I can't wait to hear the speaker myself. Now, I'm a research physicist, but I also work with BBC Television and the Discovery Channel, and I get to interview some of the greatest minds of science and philosophy. And every time I interview these people, I ask them the key question, the question of all questions, the question that has haunted philosophers and scientists for generations. And that question is there intelligent life on the Earth? Well, I was watching the Kardashians on TV last night and, no intelligent life on this planet. But actually, there is one question of all questions that really has haunted the greatest minds for the past 2,000 years. Is there a unifying principle, a paradigm, a all-consuming theory, a God equation that would explain the richness, the variety, the splendor of our universe? And that's the story of my book, The 2,000-Year Chase to Find a Theory of Everything. An equation, perhaps no more than 1 inch long, that eluded Albert Einstein for the last 30 years of his life. Well, let's talk about the God equation, because it has consumed the finest minds of the human race. Hundreds of physicists are working with atom smashers, working with detectors in outer space to try to unravel the secret of the universe itself. In other words, the God equation. An equation, who knows, maybe no more than 1 inch long, that will allow us to, quote, read the mind of God. Well, I first heard about this theory when I was 8 years old. When I was 8 years old, something happened which changed my life completely. When I was 8 years old, everyone was talking about the fact that a great scientist had just died. But on the evening news, all they published was a picture of his desk. And on the desk was an unfinished book. And the caption said, "The greatest scientist of our time could not finish this book." Well, I was mesmerized. I said to myself, wow, what could be so hard that he couldn't finish it? Couldn't he ask his mother? I mean, it's a homework problem, right? Everything is a homework problem. Why couldn't he finish it? Well, I was consumed with trying to find out Who was this man, and what was so hard that he couldn't finish it? I found out that his name was Albert Einstein. And what he couldn't finish was the theory of everything that would allow him, in his own words, to quote, read the mind of God. Well, I decided when I was around 17 to be part of this great revolution. So I asked my mom one day, Mom, can I have permission to build an atom smasher in the garage? A 2.3 million electron volt betatron particle accelerator? And my mom kind of stared at me. And she said, sure, why not? And don't forget to take out the garbage. Well, I assembled 400 pounds of transformer steel, 22 miles of copper wire, and I built a betatron particle accelerator in the garage. And I blew out all the circuit breakers in the house. My poor mom, she must have said to herself, why couldn't I have a son who plays baseball? Why can't he play basketball? And for God's sake, why can't he find a nice Japanese girlfriend? Why does he build these machines? Well, I wasn't the only one mesmerized by the search for a theory of everything. You see, for 2,000 years, the greatest minds in history, like Democritus, shown here, he thought that atoms were the basis of reality. Aristotle thought that 4 elements made up the entire universe, but it was Pythagoras who had the most ingenious idea. He said, it's music. Only music is rich enough to explain all the richness and variety of the universe. So one day, Pythagoras was noticing a lyre string. He plucked it, and the longer the string, the lower the note. And he went by a blacksmith shop, and he saw a sword being hammered. The longer the sword, the lower the note. And he said, aha, aha, mathematics can explain music. The mathematics of resonances. Each note gives you a vibration that can be measured in the laboratory. This was a breakthrough. He even founded a school to discover music and the laws of melodies, the laws of harmonies. Unfortunately, the Roman Empire fell apart, and for 1,000 years, there was darkness, superstition, magic, and inquisitions. And then in the year 1666, there was the Great Plague that hit London. 1/4 of the population of London perished in this huge epidemic. One man was 23 years old. He was sent home because Cambridge University was locked down, and he noticed an apple fall on his estate. And then he saw the moon. And then he asked a question for the ages. If an apple falls, does the moon also fall? Well, he realized that yes, the moon, celestial bodies, comets, they're falling. They're falling in free space. But the mathematics was too great for his time. So what did he do? He discovered calculus to solve the falling apple and the falling moon problem. His name was Isaac Newton, and he created the first theory of almost everything, an equation that summarized the laws of motion. And this set into motion the Industrial Revolution. Mechanics, steam engines, buildings, tensions on bridges, all of it could be calculated using Newton's laws of motion. So whenever a force is unraveled, it changes human history. Think about that. There are 4 forces that govern the universe. Each time a force was unraveled, it changed human history, with Newton's laws unleashing the Industrial Revolution. Amazing. And then 200 years later, Faraday and Maxwell worked out electricity and magnetism. And Faraday showed that if you vary a magnetic field, you get an electric field. If you vary an electric field, you get a magnetic field. And that gave us dynamos, generators, light bulbs. The electric revolution took place because, once again, a unifying theme emerged. Electricity and magnetism are 2 sides of the same coin. In the same way that Newton unified heavenly physics with earth-like physics, Faraday and Maxwell unified electricity with magnetism. And then Maxwell made the observation for the ages. If an electric field can create a magnetic field, and a magnetic field can create an electric field, can they vibrate? Can they vibrate together to create a moving wave? Well, he then calculated the speed of this wave, and he was shocked out of his mind. The speed of this wave was the speed of light. And then he said, this is light. That's what light is, the unification of electric and magnetic fields, each one turning into the other. And so the universe was simpler than we thought. Radio, television, microwaves, ultraviolet, X-rays, gamma rays, all of that summarized by the work of Michael Faraday and James Clerk Maxwell, unifying electricity and magnetism. And then along comes Einstein, who says E equals mc squared. M is the mass of hydrogen in the sun. E is the energy of sunlight. In other words, E equals mc squared, unified matter and energy, giving us the stars. The secret of the sun lies in the unification of matter with energy. So once again, it is unification that is the fundamental theme of the universe. But the question is, unifying what? What is being unified? Well, before World War II, a new philosophy began to emerge. First of all of biology can be expressed in terms of chemistry. All of chemistry can be expressed in terms of physics. All of physics, in turn, can be expressed in terms of two theories: relativity, the theory of the very big, like big bangs, black holes, and the theory of the small, which is lasers and transistors, computers, the internet. This conversation is made possible by the quantum theory. But the problem was, these two theories don't like each other. Why should God have a left hand and a right hand that don't talk to each other? No, not possible. There's got to be a unification of the left hand and the right hand. Well, then we had World War II, and it showed the power of this theory. Once again, when a unification of a principle of force was unraveled, it changed human history. First, we had the Industrial Revolution. Then we had the Electric Revolution. Then we had the Nuclear Revolution. And then after World War II, we began to smash atoms. And what did we find? Chaos. A zoo of subatomic particles emerged. This was not supposed to happen. G. Robert Oppenheimer, father of the atomic bomb, said in frustration, quote, "The Nobel Prize in physics should go to the physicist who does not discover a new particle this year." Physics was in turmoil. Why should the quantum theory of particles be so messy? Things are supposed to be simpler. That was the lesson we thought we learned. But then, nope, nature had other plans for us. So we built bigger atom smashers, much bigger than the one that I built when I was in high school. Big, gigantic, large hadron colliders, smashing protons together at 14 trillion electron volts, and this is what they found. It is an ugly, it is a clumsy theory, but hey, it works. At the low energy, it does explain electrons, protons, quarks. It's called the Standard Model. The Standard Model is, well, quite ugly. It's a theory that only a mother can love. It has 36 quarks and antiquarks, 3 identical generations of redundant particles, 20 free parameters that you can adjust any way you want. Look at this thing. Why should God be so fundamentally chaotic and random at the fundamental level? There's got to be a higher theory. So this is the low energy theory, but what is the high energy theory? Well, 2 weeks ago, you probably saw it in the New York Times. 2 weeks ago, a crack was found in the Standard Model. The first crack, by the way, in 50 years. For 50 years, this clumsy model has held sway because it works. But at higher energies, it must fail. Why should nature be so malicious to create a universe with a left hand and a right hand that don't talk to each other? And one hand, look at this, a mess. That's why people are saying there's got to be a principle, a paradigm. There's got to be a paradigm that somehow unifies all this zoo of subatomic particles, and we think it could be music. The music of subatomic particles. You see, a violin string, each note corresponds to a vibration. But if I had a microscope and could look into an electron, I would not see a dot, we think. I would see a rubber band. And when you twang the rubber band, it changes frequency, and you have to give it a different name. So you call it a neutrino. You twang it again, changes frequency, and you have to give it another name, so you call it a quark. You twang it enough times, and this rubber band gives you all the subatomic particles in nature. This is called string theory. So in other words, why do we have so many particles? They're nothing but notes on a vibrating string like A, B flat, C sharp. What is physics? Physics is the harmonies of these strings. What is chemistry? Chemistry is the melodies you can play when these strings bump into each other. What is the universe? The universe is a symphony of strings. And then what is the mind of God that Einstein spent 30 years of his life chasing after? The mind of God would be cosmic music resonating through hyperspace. That, we think, could be the mind of God. In fact, you can summarize all of string theory into one equation. That's my equation. My equation is about 1.5 inches long. It's not the final equation, however, because more recently we discovered that they are membranes, like beach balls or volleyballs, membranes that can also vibrate. In fact, we think our universe is a membrane. So therefore, this is not the final equation. This is not yet the God equation. But maybe somebody out there listening to this program, a young person who's energized by this talk, maybe you will find the true God equation. And when you do, let me give you some advice. First, tell me first. And we'll publish together and we'll split the Nobel Prize money. Now, then the next question is, how can you test a theory like this? Well, there are 5 ways you can test this theory. You can look for new particles and forces, a 5th force, like what happened just 2 weeks ago at Fermilab outside Chicago. A crack was found in the standard model. Maybe that crack can be filled by a particle predicted by string theory. In other words, the next octave up. We are the lowest octave of vibrating strings, but they're higher octaves. Maybe the next octave can explain this discovery made 2 weeks ago. And dark matter, which makes up most of the universe. Dark matter is invisible, but it's predicted by string theory. Plus gravity waves, I'll talk about that in a minute. The instant of creation itself may be photographed using gravity wave detectors. New accelerators are being proposed by the Japanese, the Chinese, and the Europeans. And maybe there are deviations in Newton's laws of gravity. So let's just take a few of these ways to test the theory. Every textbook, every high school textbook usually says that the universe is made mainly of atoms. Wrong. That's not true anymore. Most of the universe is made out of dark matter, which is invisible and predicted by string theory. String theory says there are higher octaves of vibrating strings. The next octave up would have invisible matter. And so this could be the origin of dark matter. Now, dark matter is invisible. So how do we know it's there? Well, how do we know that your glasses are there? Well, light bends when it goes through your glasses. That's why we know there's glass there. And the same thing with dark matter. Light bends when it goes through dark matter. That's how we know that dark matter really is there. And it could be nothing but a higher vibration of the string. And the questions that children ask, maybe the string theory can answer them. Children ask the question, Mommy, Daddy, if the universe is expanding, what is it expanding into? And children ask the question, if you fall into a black hole, where do you go? Or is time travel possible? Can you go backwards in time? Or are there gateways, wormholes to other universes? What lies beyond the black hole? Is there a white hole on the other side of a black hole? Are there other dimensions? Are there other universes? None of these questions can be answered within the current framework. You need a higher theory. And that's where string theory comes in. So let's try to test this theory. The European Space Agency and NASA are proposing to get baby pictures of the instant of creation. This is LISA, Laser Interferometry Space Antenna, a gravity wave detector in outer space proposed by the Europeans and the Americans. It'll give us baby pictures of the infant universe, a trillionth of a second after its birth. And when we analyze these baby pictures, we'll see the universe, the infant universe emerging from the womb. And maybe, just maybe, we'll find evidence of an umbilical cord connecting our infant universe to a parent universe in a parallel universe. And what's on the other side of a black hole? If you fall in, do you just die? What happens when you go through a black hole? Is there a white hole on the other end of a black hole? Well, in 1935, Albert Einstein and his student Nathan Rosen devises the Einstein-Rosen Bridge, shown here. It connects two universes together with a bridge, the Einstein-Rosen Bridge, connecting our universe to another universe. And perhaps that other universe is in a different time, in which case this would become a time machine. So think about it. Physicists are now meeting the world of science fiction. Now, you've seen this before. Where have you seen this before in a children's book? Well, years ago, there was an Oxford mathematician by the name of Charles Dodgson. He knew about wormholes. Mathematicians call them multiply connected spaces. They don't call them wormholes. The press calls them wormholes. However, Charles Dodgson decided to write a book about them, and he could not use his name, of course. He was a distinguished professor of math. So he wrote under a pseudonym, Lewis Carroll, and he called it Through the Looking Glass. The looking glass is the wormhole, a gateway between our universe and a parallel universe. And then the next question I'm sure you're going to ask me is, if there is a gateway, a wormhole between us and a parallel universe, then is Elvis Presley still alive in a parallel universe? And the answer is probably yes, according to the quantum theory. So we're talking about a multiverse of universes now. It was Einstein who said that our universe is a bubble of some sort. We live on the skin of the bubble's expanding. That's called the Big Bang theory. But string theory says there could be other universes out there. And when these universes collide or fission, that's called the Big Bang. So the Big Bang could be a collision of the multiverse, a multiverse of universes. Now, I find this aesthetically pleasing because you see, my parents were Buddhists. And in Buddhism, there is no beginning or end. There's just nirvana. But I was raised as a Presbyterian. And in the Presbyterian religion, there is an instant when God said, "Let there be light." There was a Genesis. So either the universe had a beginning or it didn't. There's no two ways around it until now. Now we can meld these two ideas together because you see, our universe had a beginning. Our universe had a Big Bang. Our universe had a Genesis, but there are other universes out there. And what are they floating in? Nirvana, a higher dimension. Nirvana is the true arena of all these universes. Now we think of space being three-dimensional, X, Y, and Z, 3 dimensions. But why 3? There's nothing special about 3. You talk to a mathematician and they'll say that 3 is actually quite ordinary, rather boring dimension. Other dimensions are much more interesting. And maybe, just maybe, we can have people living in these other dimensions. This was Edwin Abbott, a novelist who wrote about Flatland, a world on a tabletop, two-dimensional people on a tabletop. Well, when I was a child, I used to go to the Japanese tea garden in San Francisco, and I would see the fish, the carp, swimming in two dimensions. They could swim forward, backward, left, right, but up and down were forbidden. The universe was flat. The universe was two-dimensional. There is no third dimension. Any fish talking about a third dimension would be laughed at, considered a crackpot, a mystic, an idiot. There is no third dimension. Well, today, many physicists believe, though we cannot yet prove, that we are the fish. We spend all our time in three dimensions, not realizing there could be 4, 5, 6, up to 11 dimensions. This is a hypercube, a four-dimensional cube. Artists and physicists have been fascinated by these higher dimensional objects, led by Salvador Dali. Salvador Dali, many of his paintings are based on the fourth dimension. This is Hypercubica's crucifixion, Jesus Christ crucified in the fourth dimension. Crucified on a tesseract, shown here. A tesseract is a four-dimensional cube. And if you saw the movie Interstellar, starring Matthew McConaughey, at the end of the movie, where does McConaughey wind up on? Hyperspace. It's based on string theory. String theory predicts there are other dimensions, and that's where Matthew McConaughey is floating in the final scenes of the movie. And of course, Salvador Dali immortalized the image of melted clocks. Why melted clocks? Because he was trying to visualize time as the fourth dimension. And of course, time could be a fourth dimension, but believe it or not, Einstein's equations do allow for time travel. Einstein himself realized that. Now, Newton, of course, thought that time was like an arrow. Once you fired the arrow never deviated. Forward, backward are two distinct realms of time. Einstein comes along and says, not so fast, not so fast. Time is a river that can speed up and slow down as it meanders throughout the universe. Time is a river. The new wrinkle on all this is that the river of time can have whirlpools. The river of time can fork into two rivers, giving us the possibility of time travel. Now, Stephen Hawking, the great physicist, looked into this question, and he concluded that wormholes through space are allowed under Einstein's equations. He had doubts about going through time, but space, yes, he believed that wormholes could, in fact, go through the fabric of space. So the question is time travel possible? Well, there's a wrinkle in all this. The equations say perhaps, but to do it, you do not need plutonium in a DeLorean. That's simply not possible. You need a black hole, the energy of a black hole. That's what it takes to rip the fabric of space and time, to turn time into a pretzel. It takes energy beyond comprehension. So sorry about that. Now, there's another problem with Einstein's theory. You see, Einstein's theory says that the universe must eventually die. This is the second law of thermodynamics, that in a closed system, things rust, fall apart, rot, decay, and die. That's why we die. We die because errors build up. The second law says errors, entropy, builds up in our cells. Our cells begin to become sluggish, and eventually they go into senescence, and eventually they die. That's why we die. But if you take a look at evolution, evolution seems to go in the opposite direction. Higher forms emerging. What's wrong with the second law of thermodynamics? Why do we exist at all? You see, I said that in a closed system, entropy always increases, chaos increases, eventually you die. But what happens if you have an open system, like sunlight coming in from the stars? That's what drives evolution on the Earth. And so, if the laws of physics are a death warrant, saying that the universe itself must eventually die, then the question is it possible in an open system to reverse the death of the universe? And the answer is possibly yes. Trillions of years from now, when we're very advanced and we haven't blown ourselves apart, the universe will approach near absolute zero. It'll get very cold. Life, intelligent life, will be impossible. All life as we know it will eventually die. But there's one and only one way to evade the second law of thermodynamics, and that is to go to an open system. In other words, a wormhole to another universe. And if we were to go through a wormhole to another universe, this other universe could be younger and warmer than our universe, which is on the verge of death. Think about that. We'll be able to escape on a dimensional lifeboat to another universe and then mess up that universe as well. We'll have two universes to mess up. But the point is that perhaps there is an application to this theory. The application to this theory is that it will allow us to survive even if the universe itself dies. Well, now what I'd like to end on is my favorite Einstein story. And then if we have time, I'll take a few questions. My favorite Einstein story is this. When Einstein was an old man, he was tired of giving the same talk over and over again. So one day his chauffeur came up to him, and the chauffeur said, "Professor, I'm really a part-time actor. I've heard your speech so many times, I've memorized it. So why don't we switch places? I will put on a mustache. I will put on a wig. I will be the great Einstein, and you can take a rest and be my chauffeur." Well, Einstein loved the joke, so they switched places. Well, this went along famously until one day, a mathematician in the back asked a very difficult question. And Einstein thought, oh, the game is up. But then the chauffeur said, that question is so elementary that even my chauffeur over here can answer it for you. Well, thank you very much.
Dr. Kaku, thank you so much. What a true honor this was. It was a fascinating presentation. Thank you.
Thank you.
And yes, we do have several questions. We appreciate your time on this. First one I've got here. For those viewers who have not yet read The God Equation, one thing this book does a terrific job of is introducing the reader to giants in the field of astronomy and physics and how one's achievement paved the way for the next. I found it fascinating that on more than one occasion, the same year that one scientist died, the next to take up his reins was born. It's almost as if the universe wants and is willing this journey of knowledge to persist. So my question is, was it difficult for you to so eloquently summarize and tell the tales of these geniuses?
Yeah, well, it is a rather astonishing coincidence. I was quite shocked when I saw this, reading the history, that the year that Galileo died, Galileo was put under house arrest. He died under disgrace. He was going blind. The year that Galileo died, a young baby was born on another part of Europe, and that young baby completed Galileo's conjectures and mathematics. That baby was Isaac Newton, who was born the same year that Galileo died. And then the torch was carried on by Maxwell. Maxwell worked out the theory of light, that electromagnetism is the source. In fact, that's what is light. And it turns out that he died young, but the year that Maxwell died, a baby was born, which carried on his work. And that baby was Albert Einstein. And so it's a cosmic coincidence that the torch was carried on by somebody who is born the very year that the predecessor died. Now, of course, we're talking about the whole shooting match, and that is the God equation. An equation perhaps no more than 1 inch long that would allow us to summarize everything known about the universe. You know, on one sheet of paper, you could write the theory of almost everything. You could put down Einstein's equation, which is about 1 inch long. And then the standard model is quite ugly, clumsy. It's a horrible theory, but it works. It's about, a foot long, or maybe more like a yard long if you were to write it out. But on one sheet of paper, you can put the theory of almost everything. Now, we want that 1 inch equation, which will merge these two hostile theories. Realize that relativity is based on smooth surfaces, trampoline nets, spheres, smooth surfaces, while the quantum theory chops up everything into tiny particles. So how can a theory of particles be equivalent to a theory of smooth surfaces? In fact, Einstein had an analogy. He wrote about marble, that gravity in space is based on smooth marble surfaces. But the quantum theory is wood. It's gnarled. It has no rhyme or reason. It's wood, said Einstein. Well, we think that both these can be combined in terms of the language of music. The music of gravity, the music of subatomic particles, all of it is the lowest octave of the string. And if Einstein had never been born, this is quite astonishing. If Einstein had never been born, we would have discovered all of Einstein's theory anyway as the lowest vibration of a vibrating string. I find that truly remarkable. And you can throw the standard model in with it too. Everything we know about the universe can be summarized at the lowest octave of a vibrating string. That is incredible.
It is incredible. All right. Next question comes from a fan. This is from Philip Peace, referring to the double slit experiment to determine if light is a wave or a particle. Philip says, as I understand it, light is a wave until it is observed. This seems to imply that consciousness is what turns energy into matter. And if so, then it seems that God is some universal consciousness that turns energy into what we know as the universe, which also fits with what the mystics describe as the sense of oneness or cosmic consciousness. So I'm left with this question. Did science uncover the existence of God with the double slit experiment?
Well, there are two major ways of understanding the double slit experiment. And by rights, an electron should go through one hole at a time. But if I have a sheet of paper and I shoot electrons through two holes, then what happens on the other side? What happens on the other side is you get an interference pattern, as if two waves interfered with each other. Now, that blows your mind. That means that the electron went through both holes simultaneously. How can that be? How can one electron go through two holes at the same time? That's just the way it is. Get used to it. So there are two philosophies you can take. Neither of them with common sense. Both of them will blow your mind away. The first interpretation comes from Eugene Wigner, who helped to build the atomic bomb, one of the founders of the quantum theory. And he said that, well, someone has to look at it, as you correctly pointed out. Somebody who is conscious has to look at the electron to say that, aha, the electron went to the left, or the electron went to the right. But who looks at the observer? Well, somebody has to observe the observer so that the observer can exist, because the observer is also made out of atoms. But how do we know that the observer of the observer of the observer can exist? Somebody has to look at him too. And so you have an infinite sequence of observers that make it possible to make a measurement. In other words, this is called Wigner's friend. That Wigner has to have a friend in order to make a measurement. So how many Wigner's friends are there? An infinite number, leading up to God. In fact, Wigner even wrote about Hindu mysticism. One of the founders of the quantum theory wrote about Indian mysticism when he talked about observers, making observers all the way up to God. There's another way to look at this. thing, which is even crazier than that. And that is parallel universes. The universe can split. In one universe, the electron went to the left. In another universe, the electron went to the right. And the two universes split apart. We are constantly splitting apart. Universes after universes being split apart. And there's even a TV series based on this. Man in a High Castle is on TV. Man in a High Castle is based on the idea that Roosevelt was assassinated in one universe, and so we lost World War II. The Germans won and cut up the United States because they won World War II because assassin's bullet killed Roosevelt. But you see, a bullet is a quantum event. A bullet, the flaring up of gunpowder depends on atoms. Atoms that could cause a misfire, because sometimes guns misfire. So in other words, in one universe, Roosevelt died and the Nazis won. In the other universe, the bullet misfired. Roosevelt went on to lead us in World War II and the Nazis were defeated. In other words, two universes split by one bullet, which in turn is a quantum event based on the laws of chemistry, the laws of chemistry and atoms. So what's the way around this? Physicists go crazy thinking about this. Richard Feynman, the great physicist, Nobel laureate, said that we still don't really understand it. We have two ways of looking at the quantum theory. Either there's a cosmic observer, i.e. God, or there's an infinite number of parallel universes. Take your pick. In other words, get used to it. The theory works. The theory works, but the philosophy behind the theory will blow your mind away. Two alternate points of view, your head explodes thinking about it.
It's amazing. So can you explain to us why it's so difficult to conceive of the 7 dimensions beyond the 4 that we're accustomed to, or rather, should I say, the 3 dimensions that we know plus time? Is there a way that it can somewhat sort of simply be described to a layman like myself?
Well, the simple answer is no. We live in a 3-dimensional world. We can move in length, width, and height. And we can conceive of animals charging at us in 3 dimensions. That's why we understand 3-dimensional tigers, 3-dimensional lions. But you see, evolution did not give us the ability to visualize a 5-dimensional tiger because they don't harm us. Therefore, there was no necessity for us to visualize 5-dimensional tigers. But your PC, your computer easily computes in n-dimensional hyperspace. No problem at all. It's nothing but a mathematical trick. So how do we physicists visualize these things? We take cross sections. In other words, we really cannot visualize a 5-dimensional being or a 5-dimensional object. Evolution didn't give us a brain big enough to do that. So what do? We slice it up. Slices we understand, even though the 4-dimensional, 5-dimensional, 6-dimensional object itself is not visualizable. So what do? We use mathematics and tricks. Tricks being cross sections in order to understand these objects. So can we visualize higher dimensional objects? No. Sorry about that. But in the movie Interstellar, Hollywood tried, and they had Matthew McConaughey floating in a 5-dimensional cube at the end of the movie.
Is that like a tesseract is sort of like a shadow of a shape in another dimension? Is that how it would be?
Yeah, let's say I take a cube, like a box, and unravel the box. What do I get? I get a cross. A cross consisting of squares, 6 squares arranged like a cross, and that is the unraveling of a cube. Now, if I unravel the hypercube, I get a tesseract. And you saw the picture, it was Salvador Dali who popularized the tesseract. In fact, in the novel and the movie, A Wrinkle in Time, the gateway through hyperspace was the tesseract, which in turn is nothing but an unraveled 4-dimensional hypercube.
Gotcha. Thank you. Some people subscribe to the saying, every answer found brings another question, or the further we go, the less we know. If you consider this, why would strings be the smallest things, the ultimate substance that make up everything? Could there not be even smaller things, and this thinking goes on indefinitely?
Well, there are two ways of looking at it. One way is that there is a final theory, given the fact that on one sheet of paper, you can write down the complete theory of almost everything, the standard model with Einstein's theory. So one school of thought says that it does end, that this is the final theory. However, you cannot deny the possibility that it goes on forever. This is called the onion theory. And we physicists do not like to postulate a new layer of the onion unless we have to. And so is an onion possible as the way in which to look at the universe? The answer is yes, but so far we see no necessity to go beyond what is called the Planck energy. The Planck energy is the energy of the Big Bang. It's the energy of the string. It is 10 to the 19 billion electron volts. That is a quadrillion times more powerful than the Large Hadron Collider, which is our most powerful machine. So string theory lives at the energy of the Planck energy, so there's no necessity to go farther. But could it go farther? Possibly. But I bet it stops. I bet you it stops at the string.
I can't even imagine the calculations that would go beyond that. Just seems incredible. I've got one more question from you, and then a favor I'm going to ask. The last question is quantum entanglement. Can you explain it a bit to our viewers and tell us your thoughts on it?
Well, if you're a fan of Star Trek, you know that Captain Kirk can communicate across the galaxy instantly using what is called subspace communication. Now, what the hell is that? Well, we think it could be quantum entanglement. If I have two electrons and two electrons are vibrating in unison and I separate them, then an umbilical cord, an invisible umbilical cord emerges connecting these two, such that if one is spin up, the other one is going to be spinning down, because the sum of the two must be zero, okay? Now, if you separate these two electrons by a galaxy, they communicate with each other faster than the speed of light, instantly. Now, Einstein hated that idea. Einstein said nothing can go faster than light. But we've done the experiment. Hey, what can I say? Einstein was wrong. The two electrons are aware of each other's presence faster than the speed of light. That's called quantum entanglement. But was Einstein totally wrong? No. It turns out that the information that goes faster than the speed of light is not usable. It's not like Morse code. You can send a message on Morse code, but the message you send on quantum entanglement is random information. So sorry about that. We cannot yet communicate faster than the speed of light. We think the only way to do that is through a wormhole. That is consistent with Einstein's theory, but quantum entanglement probably is not the way to communicate faster than the speed of light. Sorry about that.
All right. So last thing here, I've watched you talk several times. I think you're one of the best speakers I've ever seen. I really enjoy it. And I know everybody watching is going to enjoy this. And I once heard you say, well, to preface, I work with young children a lot every day, and I'm sure many of them are watching this presentation. I once heard you describe your thoughts on what the meaning of life is and why we are here. Could you let our viewers know what you think the meaning of life is and what our purpose is here?
Well, let's talk about the meaning of life for humanity in general, and then the meaning of life personally. I think the meaning of life for humanity is, well, it's a chess game that after 2,000 years, we finally figured out how the pawns move, how the bishops move, and how the knights move. But our destiny, our meaning, is to become grand masters of the game of chess. In other words, to find the God equation, and then to make use of the God equation, to be able to use it, okay? Not just marvel at its beauty and its elegance. So I think that's the destiny of humanity, to find the theory of everything. That is our destiny. Now, what about our destiny as individuals? Some people think that we just sit back and some guru from a mountaintop comes down from the mountaintop and says, here it is, folks. This is your meaning of life. I think that's too easy. The meaning of life for me is to struggle to find your own destiny, because it's too easy. It defeats the whole purpose. What's the purpose of having a meaning of life if somebody simply tells you what it is? No, the purpose of life is the struggle to find your destiny. Each of us, I think, has a destiny, and our meaning is to struggle to find it, because otherwise it's given to you on a platter, and that defeats the whole purpose. The whole purpose of looking for the meaning of life is to find that struggle that revealed to us our personal destiny. In other words, we create our own destiny. Our destiny is created by us because we struggle to find it. It's too easy to have somebody give us the meaning of life, because that defeats the whole purpose of the meaning of life. At least that's how I see it.
That's wonderful. Dr. Kaku, I can only imagine the amount of preparation and work that goes into touring a newly released book. Your knowledge, insight, and time is truly valued by us. And on behalf of myself and our viewers, I want to thank you for being with us today.
Well, it's been my pleasure and a great honor to speak here today at the Gaithersburg Book
Festival.
A great honor and a great pleasure.
Thank you. And I would like to thank all of you for joining us for tonight's presentation. We have an amazing lineup of programs for both adults and children throughout the month of May. You don't want to miss one. Please go to Gaithersburgbookfestival.org and look over the schedule so that you can plan out your festival month. Before we sign off, we have a special message for you from the amazing author and bookstore owner, Ann Patchett, and her dog, Sparky. Enjoy, everyone, and good night.
I'm Ann Patchett here at Parnassus Books with my dog Sparky, and I want to tell you the importance of supporting your local independent bookstore, Politics and Prose. They are a remarkable partner with this book festival. Now, when a book festival is live, it's really easy. You just go to the table and you buy your book and then you go to the event. But when a book festival is virtual, it gets a little trickier because you're home and you might think, well, I'll just buy the book on Amazon. So I'm here to tell you, don't buy the book on Amazon. For one thing, Jeff Bezos has enough money, right? He's trying to colonize the moon or something. He doesn't need anything that you've got. Politics and Prose, on the other hand, they're your local independent bookstore, and you love them, and they bring you so many events. They work harder than any bookstore I know in their community. And if you want them to be there alive and healthy and well when all this is over, you actually need to support them. They are the people that are putting a tax base in your community, okay? So you have teachers and police officers and firefighters, and when you pay a couple dollars more for a book, you're creating jobs in your community. So enjoy your book festival, support Politics and Prose. Remember, Ann Patchett and Sparky think it's the thing to do. Shop local. Thank you.